went to the C++, and I went to the Python.
Interesting.
But in the 4 times.
Okay. I'm guessing they're quite a bit more populated.
Yes. Well, they were in the 4 times. I don't know if this exists.
Yeah, I'm sure they do.
Testing.
Yes.
1, 2, 3.
Been on the go for
1, 2, 3.
a
Okay.
year maybe? Or maybe a year now. Do you guys use Lisp at your jobs or just generally interested?
Programming Emacs, so yes.
Oh, cool. Oh yeah. Do you get to use that in your job?
Cool.
I don't use it either. I use TypeScript.
Cool. Actually, now that we're actually using this stuff. Just keep the code.
Okay.
Write some so like functions.
So connected to the
So
code.
yeah, what I did was like a quick code, like a header code, and it was going into this, and this piece was like. That's file steps. So I was writing some functions for these schemes. So we mixed code base. It was a written scheme which I never ran into before, but yeah, it was very easy. For nine languages. Functional language was to be part of the process overall, but that's also the language that combined. And then this was actually so I was familiar with syntax and how it works, and then scheme is very similar. So for me, and it was fun. I liked it. It's already so it was really fun. And then see how it works all together.
What's the domain you're on? Data science or website?
Yeah, this goes is like operation research, like we are searching like another programming utilization basically. And before it, for just I was like use of the social license. One is like imagining it process.
So Simon will check downstairs one more time to see if there are anyone, and then we will begin. Okay, everything is set up.
Guessing you're going to talk about slime at some point. It's the
Slime.
It's like
Yeah,
I know, I
we-
can excuse slime.
Oh, right.
Let's go.
okay. Yeah, it's the Emacs mode for Common Lisp for the Emacs guy. So you're a Common Lisp fan?
Fan, although I mostly write because what's the fun these days. Yeah. My
That's
first job
very
was
well data science. So Python is everywhere now.
Yeah. I don't know.
I never spent the year just representing.
I don't know if Quick Lisp was around when you used Common Lisp. It's like a package manager.
Yeah, I'm just using SBCL.
Right. That's been around since
Yeah.
the 80s or something. Some version of it.
Do you actually get to use this via Meetup?
No. You're saying you get to use a bit of Scheme.
Oh, yeah, yes. Scheme is a nicer, smaller language.
Well, I don't know if I sort of I think it is. I like to avoid very simple.
Purer, definitely.
Yeah, maybe. It wasn't my decision. It's just like came out. Yeah. I like those sort of like sometimes.
Yeah, I think it's a good gateway drug, right? I mean, I think the way I got to this USP languages was, I think I had a cousin who gave me his used a copy of ZigBee,
The
structured
yeah.
programs.
I've some people who are using Clojure.
Yeah,
It's like for scheme or whatever. So this seems just for the
yeah, I have a epidemiologist friend who uses Clojure a lot.
I never used it myself, but I was my project.
Yeah, I think it's a decent
we were
trade-off, right?
using
Yeah.
Clojure, so it was.
I think a lot of Lisp purists sort of hate it.
I get the sense that it's the most used in industry.
Yeah, maybe.
It's also a .NET flavor of this part.
Sorry.
I mean, Clojure is on the JVM.
Yeah.
Something very similar for the CLR as well, right?
I don't know. Yeah, might be. I don't know. But I don't know about the JVM version.
I mean, there's a version of this for every
But for the
interpreter.
yeah for the CLR there are middle languages around times.
I
It
know,
was even done by Microsoft. So,
Yeah, ML variant is.
there's definitely something like that because they have every language that was like is built on it. So they have a Lisp or Scheme version and also some raw version that was on it.
How did you all hear about the meetup, by the way? It wasn't through Reddit or the Devil
I
Air?
don't remember what it
So
was.
Reddit-
I think it was a Meetup page, not just by because Reddit meetups.
My brother found it on Reddit. Not on Reddit. I used to work for Reddit a long time ago, but I was on Reddit. And he told me, so this meetup
Oh.
in Dublin. He lives in Amsterdam. I'm actually quite surprised that this.
I actually had a suggestion on the Meetup page where you have
Okay.
suggestions as like similar groups. So I saw it there, and Thursday I thought about it at the time. So I like programming, so
Clojure can target the CLR.
Okay.
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 According to what I got back, looking that it's not some Gen AI crap.
I've never used .NET or anything, so.
well, yeah, I was using iOS a long time ago. I was using Java, but also I was using things like around 2000. So it's like 25 years ago. I was using Java 12.
So I don't know enough about CLR, but one of my biggest pet peeves with JVM is done to tail call optimization.
To the position.
Tail calls.
Oh.
Yeah. And you probably cannot implement something like Scheme if you don't have TCO. Right?
Yeah, it's mandated by the specification.
Yeah, I mean it's the same thing with the Python VM as well.
I think in Clojure you have to have this keyword
Yeah,
that
so I saw
specifies
this
that
in
you're doing.
Scala, which has a very weird syntax. If you're
Yeah.
defining self-recursive functions, you have to specify it as you have to explicitly specify it. It's such a word.
Yeah.
You have
Well,
to
there's
say
also in other languages, I think.
let and let rec.
And also in that's in OCaml.
Okay, also has the same thing.
OCaml also has something similar.
Yeah, I was like, well, why is the compiler so stupid? I mean, can't tell my function's recursive.
Well, it's just more part of the next. I don't know, but they I saw it somewhere. I think it was OCaml.
Interesting that you found it through Reddit because we were before this we were using Meetup basically. Get people, but
Yeah, that worked
I don't-
more is
So, starting now. Welcome back to Spiral. I'm your host Yaroslav Khnygin. I see new faces here. Very good. So, in my previous talk, I was talking about, I was giving an overview of Common Lisp as a language, and it was a very long talk. It stretched to 2 sessions even. This talk will be much shorter, I hope. This time I will talk about the development tools for Common Lisp and about Common Lisp as a development environment. So Modern development environment is a set of multiple integrated tools, and for some languages it can be a single product like Visual Studio for C++, or it can be a set of different open source tools integrated together. So with Common Lisp, it's more common to build your own environment. Although there are commercial IDEs for Common Lisp as well. So what tools are making up the Common Lisp development environment? It's a language implementation, a build tool, a system manager, and code editor. And the language implementation is what actually executes your code, so it can be either a compiler, or it can be an interpreter, or even both in some cases. So there is a common misconception that Lisp is an interpretive language, but this is not really true, and it's wrong to say from programming language theory there are no compilers.
Presumably it was true in the past. When did that change?
Common Lisp. I was going to talk about that. So Common Lisp was compiled from the beginning, and Lisp in general, the very first compiler appeared in 1962. There's a good article about the first Lisp compiler. So it was developed by MIT people, I think. So if you go by the link, you can read more about that. And Common Lisp was compiled from the beginning, so the very first implementation was a compiler. And nowadays the most popular implementation is SBCL, which is an abbreviation for Steel Bank Common Lisp. It's a high-performance compiler. But in some cases, for some very niche applications, it can actually drop into interpreter in case where interpreting is faster than compiling. I think it was implemented recently. Before that, it was a compiler only. So it was forked from CMU Common Lisp, or Carnegie Mellon University Common Lisp, which is the first implementation of Common Lisp from 1980. It was forked originally to make it easier to build and maintain. So SB name means both Steel Bank and sanely bootstrappable. It supports all major platforms like Linux, Windows, Mac OS, ARM, x86, and it's the only implementation I know that actually supports RISC-V, which is an upcoming CPU architecture that is currently most popular in embedded applications, but there are also companies working on server chips as well and workstations. So SBCL is the only implementation that supports these new chips, which is great. This was implemented very recently. And there is even someone is working on a port of SBCL to a gaming console, Nintendo Switch, which requires some specific changes to the runtime. And this port is being worked on by the developers of a game called Candria. Maybe you've heard about it. It's probably the most well-known game written in Common Lisp. So and Google is a major user and contributor to SBCL. They actually implemented that interpreter that I mentioned earlier, and they're using it in the core of Google Flights. This was originally a startup they acquired, and it was written in Common Lisp, so they integrated it and they keep maintaining this Common Lisp code, and they also maintain this implementation. So you can find this implementation and download it on this website that is listed on the slide, and you can also find the documentation there as well. And if you have a Linux distribution like Ubuntu, you can just do sudo apt install sbcl and it will be installed very easily. You don't need to download anything else. It's just in the main repository, and it's also in Homebrew for macOS as well. So sbcl is more than just a compiler. It also includes a debugger, two kinds of profilers, a deterministic and a statistical one, and it has its own REPL if you want to use it directly in the terminal, but usually it's used behind our environment we are going to talk about. So yeah, it is fully ANSI compliant, so Common Lisp is standardized by the American National Standards Institute, so SBCL fully implements the standard, but it also has its own extensions. For example, meta-object protocol, which you can use to extend the object system, and it's a de facto standard rather than a legal standard, unlike ANSI. And there are native threads or POSIX threads for multiprocessing. There are BSD sockets for network programming. There is a firing function interface to use libraries, for example, written in C and other languages. And there are also extensible streams and sequences and more stuff. So yeah, it's a very feature-rich implementation. So yeah, and also there are just threads and sockets. There are other POSIX functions available directly from SBCL as well. So yeah, you can produce. So not all Common Lisp implementations produce standalone executables, but SBCL can with the function memory called save Lisp and die. So it outputs an exe file or a Linux binary if you want, that you can just run instead of loading your program. Sorry?
Would that build in all your dependencies?
Yeah, it builds everything into the executable, and because of that, the executable can be pretty large compared to other languages, but in the
I think it has a very interesting historic aspect, which is that Lisp is an image-based language.
Yes.
And predates file systems.
Yes, so it basically dumps the entire heap into an executable that contains everything that was loaded during the build process. Yeah, and the executable can be pretty large, but in the age of Electron applications,
It's like 50 megabytes.
Yeah, it's not that big deal as it used to be. So yeah. And SBCL is, I think, the only Common Lisp implementation that implements parallel garbage collection, which was done by Haley Patton very recently. And so it's an optional garbage collector. It is slower on single-core machines, but it scales with the number of cores in your system. So
is it a precise GC?
Yeah, I think it is a precise GC. But yeah, there is a paper on it that was written by Haley Patton. I can share it with you. So the second popular implementation is CCL, or Closure Common Lisp, not to be confused with another Closure, which is a programming language. This programming is very like this very much Closure. So there's some collision there. Yeah, so it's also a compiler with good performance, but it's I think it's a bit slower than the CCL, and it has a very similar set of tools and extensions, and it was originally being developed by Apple from somewhere in the 80s until 1994, when they sold it off, and then it was open sourced. And yeah, Apple was a big user of Lisp in the late 80s and first half of the 90s in their advanced technology group for a lot of prototyping. They sold this implementation, and eventually it was open sourced, and then it was renamed to CCL, or Closure Common Lisp.
Are there domains where you would prefer CCL to SCL?
Yeah, so the main reason to prefer CCL has been historically a much better integration with macOS. It has an Objective-C bridge and its own IDE with a native interface builder. So this is very convenient, but unfortunately there is one issue, is that the old maintainers that were developing this for decades have moved on mostly, and CCL got in some got a little bit abandoned for a while, but currently one old-time maintainer returned, and he is working on porting CCL to Apple Silicon, which it currently doesn't support. So unfortunately, even though it is the best implementation for macOS, you can't use it on current Apple machines, but hopefully it's going to be fixed soon.
So, interesting aside, Apple still ships a copy of a scheme interpreter. I don't know if it's an interpreter or compiler with every copy of macOS and iOS.
Yeah, that's in their security.
Yeah, the sandbox rules are written scheme dialect.
They extend scheme to specify rules for their sandbox, I think. So that's pretty cool. So otherwise, CCL works on Windows, Linux, Intel versions of macOS, and even FreeBSD as well. So it can also produce standalone binaries with the save application function, and you can find this implementation on this website, this slide. So the next interesting open source implementation is Embeddable Common Lisp, or ECL. So it's a combination of a compiler that takes Lisp code and produces C code, which you can then compile with your whatever C compiler you use on its own, or you can integrate it into your C program. So it uses the same function, the same function call conventions. So it's very easy to integrate into C programs as an extension language. So, for example, you can use it to script a game engine. Someone is already using that to script Godot engine, which is probably the most popular open source engine right now. So another part of ECL is a bytecode interpreter, which allows it to be ported to platforms that don't have a C compiler available. So
this is the only implementation that can run in WebAssembly, so in your browser. More efficiently than with compilation to JavaScript, for example. And yeah, you can try the demo of a running ECL implementation in your browser by this address on the slide. And another great thing about it is that you can easily run it on Android and iOS, so on mobile platforms. It's much harder to do with other implementations, so it's the #1 choice for mobile applications. And there is a nice binding that combines ECL and Qt on Android. So if you want to write an application for Android, this is a good choice. It can also run as an ordinary standalone implementation on basically any operating system you want on desktop, so Windows, Linux, macOS, BSDs, ARM, on x86. So yeah, you can find the site here. And the final open source implementation I'm going to cover is Clasp. This is the newest implementation out of the 4, and it's a compiler that is based on the most popular generic compiler framework called LLVM, which is used also by Clang. And it is slower than, surprisingly, it is slower than SBCL by a factor of 4, or well, 4 by 10, something between 4 and 10. So even though it leverages LLVM, it's still slower than SBCL, so it's kind of hard to beat. But the fact that it uses LLVM gives it a huge advantage if you want to integrate your Lisp code in your C++ code. It can do that so you can do that very easily with Clasp, and you can even profile your Lisp code together with your C++ code with the same profiler, which is very nice. And originally it was developed by Christian Schaffmeister and others for a molecular biology work and for something called Cando. So it's a molecular design environment for biochemistry. And I recommend you to search his name on YouTube. He has a number of talks and podcasts where he talks about both his biochemistry work and about development of Clasp. And there's also the website where you can find more information about Clasp. So yeah, this is the newest implementation, and it's very actively in development. So maybe in the future it will also pass other implementations and performance as well. So and there are other open source implementations that I'm not going to go into detail about. For example, there is ABCL, which is running on top of Java virtual machine. There is JSCL, which compiles Common Lisp into JavaScript and runs in your browser that way, but it is less complete than these 4 implementations. So it doesn't implement the ANSI standard 100%, but it's still pretty usable if you want to write something in your browser. So in short, SBCL is the fastest implementation and it's actively developed. CCL is a bit slower. It has the best macOS integration, but unfortunately without ARM.
and it has some maintenance issues because of the maintainer turnover. And then there is the CL, which has the best C integration, and it runs on WebAssembly and mobile. And finally, there is Class, which has best C++ integration and is using LLVM tooling. So I will briefly talk about commercial implementations. Today there are basically two of them. One is by France called Allegro Common Lisp. Another is by Lispworks by the company with the same name. And they're pretty close in terms of their performance and feature set and their complete environment. So you get not just the compiler, but the nice code editor, a set of libraries, and other tools. They're pretty expensive for individual users. There is a free edition, but for both of them. But for Lispworks, for example, it shuts itself down after just 5 hours of use. So it's basically a demo version.
They're like $2,000 or something.
Yeah. So I tried to check the prices for Allegro Common Lisp, but they don't even list them on their site. You need to email them to ask. So that usually means it's very expensive.
Very enterprise.
And Lispworks, if you go to their site, they're selling a bunch of different licenses. So they have at least 2 tiers. And they also sell non-commercial licenses as well that don't have this 5-hour limitations. And so the one thing that bothers me about it is that for each platform you have to buy a license separately. So you have to buy. So if you have, for example, an ARM machine and an x86 machine, and they're both running Linux, you have to buy 2 licenses, one for x86 Linux and another for ARM Linux. And separate license for Windows and whatever else. And so the 64-bit licenses cost around 2,400 euros. So it's for me it's a bit pricey. So
is it some sort of an annual thing?
No, it's a permanent license. But if you pay, I think, 400 euros. So yeah, it's you get the current version permanently. But if you want updates, you have to buy them. And if you pay 400 euros additionally, you get 1 year of updates.
Sounds like a JetBrains model, just a little more pricier.
Yeah, so it's a bit pricey, yeah. And they're also selling commercial support. So if you want commercial support, you go to 2 of these companies. For example, they have a pack of 5 incidents for 1,000 euros. So yeah, it's pricey. But these are very feature-rich and mature implementations. They have pretty good performance, although I think MVCL is still faster than both of them. But they have. So Lispworks has a very nice user interface library called Cappy. It runs on Windows and Linux and macOS. It's one of the best solutions for making desktop user interfaces. So some people buy it for that reason. And France offers a very sophisticated vector and graph database called Allegro Graph for their Common Lisp implementation, which is also, I've heard, quite good. So if you want some of these add-ons, you might consider one of these commercial implementations instead of free open source implementations.
Yeah, and another advantage is in these commercial applications have is that they implement tree shaking, which means they can, so they don't just dump their entire heap when they produce an executable, but they slim it down quite a bit, so you get smaller executables than with open source implementations. And that's for some people that's important. And Lispworks also has pretty good support for iOS and Android development, as I've read. So yeah, they're very pricey, so personally I stick to the open source versions for my needs. So yeah. Now that we're done with implementations, let's talk about systems. So systems is basically, so I'm going to quote the Common Lisp book. A system is a collection of Lisp files that together constitute an application or a library that should be therefore managed as a whole. So in other languages, they're called packages, and but Common Lisp has some terminology for things, so we call them systems. And the thing that deals with these systems is the build tool, and there were historically different build tools over the years, but currently everyone uses just one, and it's called ASDF, or another system definition facility. It is included with every Common Lisp implementation, both open source and commercial, and you don't need to install it separately, which is very nice. So it looks for the systems in these two directories inside your home directory. So if you place your system there, you can load it with the load system function. And if your system defines some unit tests, you can run it with test system. You can run them with test systems and get the result. And so if we want to define our own system, we need to create a directory for it in these standard directories for SDF. Move all of our files there and create a special file with the ASDF extension, which contains this code. So you can specify the name of your system, a description, its version, also license, and what is more important, you specify its dependencies, other systems, in this case, for example, it's a pattern matching library and a command line arguments parsing library, and you specify the components of your system. So these are the packages. So package in Common Lisp is called module in Python, for example. So you can specify so you need to specify all of your files here and in which order they should be loaded. So what depends on which file depends on another one. So there are quite a few more potential arguments for this dev system function or macro. You can read about them on this web page, and there's a nice tutorial for SDF in the Common Lisp book by this URL. So I encourage you to read that as well. So where do we get new systems? We can download them from a system manager. So system manager is basically what so you can ask it to install whatever system you need, and it will also download every dependency from its distribution. And the most popular system manager is called Lisp. It was developed in 2010 by Zach Bean then you can find it by this address. It's very easy to install. You just need to download a single Lisp file from the site and execute it, and it will install everything else automatically. And then you can load whatever system you want with this quick load function. And the distribution contains more than 1,500 systems, and it's manually curated and updated by Zach. And if you want to add your own system, you can create a GitHub issue in his repository, and he will add it in the next release. And you can also add your own systems locally to this directory. So it's more convenient than doing it through ASDF, because it will install whatever dependencies your manually installed system needs. So I use that quite often. One issue with QuickLisp, as is by default, is that the releases are not very frequent, and the packages in the distributions or systems in the distributions can get outdated, or they don't get added fast enough. So to solve that, someone Alexander Artemenko, to be precise, created his own QuickLisp distribution that is moving much faster. So instead of keeping its own copy of every system, instead it downloads them directly from GitHub, and you can register them directly on the web interface of QuickLisp by linking your GitHub account. So it's so much faster to add your own system there. But since it's directly downloaded from GitHub, no one is controlling whether these systems are compatible with each other. So it's a bit less stable than the default QuickLisp distribution. So and there are others. There are other system managers. CLPM, OCICL, and Pulot. They appeared after QuickLisp, and one main potential issue they're solving is that every system in QuickLisp basically has only one version that matches the version of your current distribution. So it's global for every project you're working on. So these system managers, they separate versions for each project, so you can have different version of the same system in one project and another one. So for large-scale development, that can be pretty important. Generally, you cannot specify the version of a system you want in QuickLisp explicitly, but you can do this in these three package managers or system managers. And another advantage they have is that they download systems over TLS instead of a raw HTTP connection. So this is an encrypted connection, which is more secure. So if you care about that, this is another reason to use these three system managers instead of QuickLisp. And another advantage that OCICL specifically has is that it is compatible with Open Container Initiative by Linux Foundation. So it is compatible with its Artifactory, so with its artifacts and with its
registries. So if you have
a workflow that already uses OCI, then it's more convenient to use OCI for that.
Just so you know, it's 26 past. I don't know if we have a hard limit.
Yeah, we have 1 more hour.
Okay.
So there these three system managers are great, but personally I'm used to Quick Lisp. It's good enough for my needs, but eventually I want to switch to at least one of these, probably CLPM. And I recommend you to start with one of these instead of Quick Lisp. But if you really want to start developing as fast as possible, then Quick Lisp is easier. Its interface is quite simpler. So yeah. So as a new Common Lisp programmer, you will probably prefer to use Quick Lisp. For a time, I recommend you to switch to these new system managers. So now I would like to talk about actually editing the code, which is you can do it. So you can do it with a Notepad, or any other simple editor, but I don't recommend it because it's just too primitive, and counting parentheses is not fun. So you can either bring your own extendable editor. It could be Emacs or Vim or Visual Studio Code or any other. I think Sublime has some kind of extension for Common Lisp. So for Emacs there are 2 extensions called Slime and Sly. Sly is just a fork of Slime. Sly has some additional features, but personally I just use Slime. And Vim has also multiple options. Vline, Visual Studio Code has the one that I know, which is called Live, and it uses the LSP protocol like any other Visual Studio Code extension. And there's also LEM, which is LEM is actually a code editor that is written in Common Lisp itself. And it works in both terminal and in GUI. And it's very similar to Emacs, but instead of eLisp, you can use Common Lisp to extend the editor. So it's very new, and actually it has binary distributions that include all the other tools that I talked about. So you can just, on Windows, you can just download them, and you don't need to install anything else. Like in DCL, it's all included in LEM binary, so it's basically a complete solution. But personally, I'm used to Emacs. This is what I use. So so Emacs is built in Solver dialect of Lisp, called Emacs Lisp or eLisp, and it has its own simple mode for writing Lisp files, but you can do better than that by installing Slime or Superior Lisp interaction mode for Emacs. You can install it from Emacs's default package manager, Melpa. So it supports syntax highlighting, it matches the parentheses, and it has also shows your current package that you're using, your current Common Lisp package. Other features it has is that it has a special buffer for read-aloud print loop, a debugger with a single stepping capability, and an inspector with hyperlinks.
So
we can inspect Common Lisp objects inside Emacs. And code indentation is very important in Common Lisp, so it handles that for you as well very nicely. You can find it, so you can just install it from Melpa, or you can download it from this website, and this is where you can also find the documentation for it. And the second link is a nice reference card for Slime. I have it open here, so yeah, this is a PDF file with all the hotkeys. So what it can do is, for example, you can directly compile the whole file. You have open Emacs with Ctrl+C, Ctrl+K, or you can just compile the current top form under your cursor with Ctrl+C, Ctrl+K. You can also quickly expand macros directly in Emacs with Ctrl+C, Ctrl+M, which helps for troubleshooting them. And you can also jump to function definitions with alt dot or meta dot. And with Ctrl+C, Ctrl+W+C, you can show function callers. And there are many other features as well. So I recommend you to download this quick reference card. So yeah. It's also you can also, as I said, it's Slime just like any other Emacs extension is self-documenting, and you can customize it in many different ways. There are various hooks you can use. And the easiest way for a newcomer to set up Emacs for Common Lisp is this installation guide, and we made a configuration file for Emacs called Emacs4CL. It's on GitHub. I have it open here. So yeah, this
I use that to set up my Emacs.
so there is this README, which has a very nice table of contents, and you can do these steps, and it also explains all the lines in this pre-made configuration file, which you can see here. So if you want to start with Common Lisp as quickly as possible, you can either download them as a binary executable, or you can follow this guide. Just download this file, .emacs, and place it in your home directory after installing Emacs. And then there are also other steps that you need to do to set up SBCL, and they're all detailed here. So yes, that's it for the slides, and I'm gonna show you how this Emacs looks like. So for example, here is Emacs. We can open this file I have here. So I have a few examples here. Let's open this. And if we do Alt X or Option X Slime, this will pop up the readable print loop prompt. So you can just evaluate any expressions here.
Can you increase the font size?
Oh yeah, sure. So yeah, you can see you can just evaluate any expressions you want, define functions, call them, and so let's see, we have so I'm going to show you a simple OpenGL example here that will draw some graphics on the screen. So if we want to run this, we can do. So we can first try to evaluate this. So as you can see, this is what the debugger looks like. These are the restarts. So as you can see, we don't have some stuff loaded, so we can do abort and just load them like that. I already have it downloaded, so I just need to load it locally, so let's do it that way. And, yeah, it has autocomplete, just tab it like that. OpenGL, and to this. So now when we load this, so we have this package defined now, and now let's open this. So this is the main file. So it's gonna open a window with a rectangle. So we can compile the full file, just like that. It's already compiled. It says how fast it compiled, it's less than a second. And then we can just call it like this. So this is its package, and this is the function. Yeah, this is our window. And we bring it to the same. So this is the OpenGL window that we summoned, and now let's try to change something in our code. For example, here is where we defined. This is where we define the color of our rectangle in the code. So we can, for example, make it red, I think. So, boom. Just like that, we compiled it, and it's already active. So the function gets replaced immediately, and this rectangle is redrawn the next frame with this new code we have after recently being compiled. So we can do it again like this. Oh, it was supposed to save the file. Yeah. So it's very quick. This example compiles faster than second, basically. So yeah, this is Emacs, and I also have Visual Studio Code here. So this is what it looks like. So yeah, this is the extension for Visual Studio Code called Live. It's in the usual marketplace. You can just install it like that. These all features here. And this is we have a very simple Lisp file open here that just defines functions. So the REPL with about print loop is at the bottom of the screen. So, yeah, just evaluate the string, it returns itself, or we can call that function. And we can see the result down there. And the history of REPL is displayed also here. And we can also inspect objects here, see all the packages, and the systems as well.
So yeah, this is it's also very simple to set up, but it's a bit more primitive than Slime currently, but it's still being developed, so it's gonna gain features over time as well. So I think that's all for my presentation. Thank you.
Thanks, Yaroslav.
Any questions?
How much do you expect this presentation to change in 5 years?
I think LLM is going to probably become the dominant option for Common Lisp development and replace Emacs as the most popular environment. So, and possibly Glasp will catch up with SBCL and overcome its performance as well in the future. But yeah, currently it's SBCL is still faster.
Lem is basically Emacs but written in Common Lisp.
And yeah, the binary distributions basically include all of these parts of the environment that I discussed in just one executable. So I expect that to become the most popular way to develop in the future. But currently it's SBCL and Emacs and Slime.
I wonder, could you show like fixing a bug live and then restarting the stack without restarting the program? That would be, I find that very cool. You just call color with like one less parameter than it needs, and then maybe.
Do that.
So yeah, it says so
it returns the
the
error.
error.
Yeah, it asks if we want to open the file anyway. So in this case, it just tells us that the error doesn't offer any restarts. Yeah, I think I can demonstrate debugging the next time because I know the better demo. But yeah, as you can see, it's very fast. Otherwise, and yeah, you see the error message. The function is called with arguments and length of at least 3. And yeah, it keeps using the old function, so I don't think it actually affected the execution yet. There's the window.
Yeah, I guess how you have your slime configured, maybe.
But yeah, so if you change the function in some way that doesn't compile, it doesn't even break your program instantly. It will still keep using the old function until you fix it. So there's that.
So there's stream going on. Yeah. Okay, I'm gonna stop the stream now.